Hello everyone. So I hope you are good and fine at your homes. And so TechInfoRay is back with another video to clear cloud concepts related to practical videos. So in my previous videos, I have covered various uh, use cases and accordingly created the different videos. So like in my previous videos, I have created a network layer practicals, elastic IP, compute, NAT gateway, load balancer, and another beautiful and very interesting auto scaling group concept. So if you want to see automation in a cloud, you can see this video. It's quite interesting concepts. And also when we want to establish communication between two VPCs, so I have created another video for VPC peer connection in the same region, and I'll create another video for different region as well. So here in this video, I'll make you aware about the transit gateway in the same region. I'll make you aware about the problem that we face with peer connection and how transit gateway solve that problem. So let's move forward and I'll clarify this concept. So this was the peering connection video that I created before. So it was a communication, and there are different use cases like two customer want to connect their virtual private clouds or virtual data centers. So we are using a VPC peering connection. So what the problem arises is, so let's move to next video, next slide. So here we have similar use cases, but the problem comes is that when we have more than one VPCs and a customer is having more than one or want to establish communication with more than one customers, and if we need to create a VPC peer connection, what it is. So if we talk about VPC peer connection, then we have to create a VPC peer connection between this one VPC peer connection between these two VPCs, second, and VPC peer connection between this third VPC. So the problem is with VPC peer connection is that as the number of VPCs grows, we have to create those number of VPC peering connections. To solve this problem and to remove this complexity of managing different VPC peering connections, then we have a transit gateway. So transit gateway comes into a picture like when we have different VPCs, VPC1, VPC2, VPC3, or customer A, customer B, and customer C. So here in this case, what we need to do is that we are creating a transit gateway and establishing the communication between all these VPCs, creating a common transit gateway and attaching all these VPCs to this transit gateway and establishing the communication. So in this practical, I have created machines in these two VPCs, and this was the illustration that how this transit gateway helps in removing the complexity that gets created to VPC peering connection in case of more than one or more than two VPCs, because as the number of VPCs grow, then we have to create more than more and more VPC peering connections. So that was the explanation why we need to move to transit gateway and how it helps to remove that complexity. So I hope the concept is clear between AWS transit gateway and VPC peering connection. So, but the main objective of these two concepts is same, that we are establishing connectivity between two VPCs, between two virtual data centers, or more than one customer, or they are overtaking the business of another customer. And we are establishing connectivity, enabling connectivity between these two customers. So that was the basic concept, but main thing is that we are removing the complexity that gets created if the number of VPCs increase. So let's move forward and see practically how we are resolving this problem and creating a transit gateway. So if we go to our AWS console, so as we have seen in the diagram, I have already created this VPC, VPC1 and VPC2 to illustrate and establish communication using the transit gateway. So these are the two VPCs, VPC2, VPC1, and these are the networks. Okay. So and similarly, there are the subnets also for different VPCs. Subnet, public subnet for VPC1, VPC2, and routing tables. So these are the routing tables for VPC1 and VPC2. Similarly, I have two separate internet gateways for VPC1 and VPC2, so that the machines that are installed in the VPC, they can have access to internet. So let's move forward and create our transit gateway. So here we are into transit gateways. So let's create transit gateway. So demo TG003, allow communication between VPCs. Okay. So let's keep these default settings. So these settings are like to it automatically adds the routing table, and so if we are using this setting, it will automatically add the routing table and automatically add the propagations in the transit gateway setting. So it helps to establish the communication. So that's the main purpose. So let's keep this settings as default. Create transit gateway, close. So it's creating a transit gateway, and it will take some time. Okay, so our transit gateway is available now. So let's create the attachments. So create transit gateway attachment. So here we will select the transit gateway that we have created. And so here we are creating an attachment for VPC, enabling a communication between two VPCs. Also, we can create a attachment with VPN, like when we are establishing communication on premises. So we will use VPN type of attachment, and peering connection when we are establishing a connection between two transit gateways in different regions, and connect while establishing on the direct connect. So these are the different type of attachments that we can create on the transit gateway, and leverage transit gateway to establish communications between different connections and achieve the connectivity types. So here we are using VPC. So let's select the VPC. So VPC1. So it has automatically selected the subnet that is there in that. Create attachment, close, and create another attachment for another VPC. So let's select our transit gateway type of attachment, VPC. Let's select VPC2, create attachment, close. So it will take some time to when these attachments get available. Okay, so our attachments are ready, and that attachment is there. So these are the different attachments that we created, and so you can see we have VPC IDs. So if we talk about 66919, so it's VPC2 attachment. So we can update it for our records. VPC2 attachment. And this is VPC1 attachment, just for records. So if we see now, let's go to the transit gateway route table. So if it automatically gets created, and important thing is associations. So these are the associations that are there in with this transit gateway that gets created automatically. So this is again the VPC2 and VPC1 resource IDs that are getting attached. And if we go to the route table, so again these get automatically propagated. So this is our route VPC2 route and subnet gateway. Sorry, subnet, public subnet for VPC2 and public subnet for VPC1. So still one more thing that is pending is that we need to update the routing tables for our subnets. So let's go to the route tables and update the routing table. That for that particular subnet we have to go through this transit gateway. So let's go to VPC1 and edit the route for this, add route. So subnet for VPC2 is 10.110/24. So it's 10.1.1.0/24. So before that, let's test if connectivity is there or not, just for testing purpose. So these are the two machines that are there. So if we try to ping these machines, so we are not able to ping, right? So these are the different machines that are created in different VPCs. So if we see that this is 10.1.0.0, this is VPC 1, and this machine is in VPC 1, and this machine is in VPC 2. So if we are trying to ping these machines, we are not able to ping. Okay. So let's update the routing tables first. So let's go to routing table, transit gateway. Save changes. Okay, so for routing table for VPC1, we have updated it. Like to go to VPC2, we have to go through the transit gateway. So let's similarly update the routing table for VPC2 and edit routes. So for VPC1, it's 10.1.0.0.24, add route 10.1.0.0./24. It should again transit gateway. Save changes. So we have updated the route tables, and now let's go to our transit gateway. We have already explained the settings and routes are updated. So now if we go to our machines, then connectivity should have been established. See, so from VPC2, VPC1, and from VPC1 to VPC2. So we are able to ping the machines between two machines. So I hope you are able to understand the concept, how we are leveraging transit gateway to establish communication between two VPCs, and we are able to ping the machines over the private IP addresses. So these are the private IP addresses from VPC1 to VPC2. So this is 10.1.1.1.2.3.4 is the machine that is there in VPC2, and 10.1.0.1.1.2 is the machine in VPC1. So we have established the communication between these two VPCs using the transit gateway. So I hope that was helpful in understanding the concepts. So I hope it was helpful for understanding the another beautiful concept and enabling connectivity between different virtual data centers, and also we can, using this transit gateway, we can establish connectivity to on-premises network also using VPN and using direct connect also. So we can establish communication from virtual data center over the cloud and on-premises data center. So that was it for this for this video, and thank you for watching this video. And the important thing is that do not forget to remove these resources, else you will be charged for these, because transit gateway is charged on per hour basis. So for the number of hours that you use this service, transit gateway, you are being charged for this. So just for precautions, you should delete these resources from the once your demonstration is over or your testing is done. So remove these resources. So that's it for this video. Thank you for watching this video, and if do like this video so that more and more people can clear their concepts for related to AWS cloud network services. And you can subscribe to my channel. I'll keep on adding these exciting videos for exciting concepts on AWS Cloud. Thank you. Bye-bye.